Hi everyone, so in this video we are going to go to layer 2. Well, I told you, as I said in the previous video, we are done with layer 1. In our case, of course, n is 2. The output of that fully connected layer with additional normalization will be used as the input for layer 2. So we'll repeat this masked multihead attention but with different weights, and also repeat the feed forward. Okay. So since we have already seen everything and it will be a kind of repetition, I will skip some details. So let's maybe look at the attention formula again, which is the softmax of Q T transpose divided by the embedding dimension, in our case is 4 times V. Okay, starting with head 1, because we are now starting with the masked multihead attention. Let's start with head 1. Query is computed by saying, okay, in the previous output, in the previous video we had x0, so it is what we will be using. We'll be multiplying it with say W10 W10 transpose. Well, x0, dimension of x0 was 2 by 4 by 4. W10, just like W1, has a dimension of 2 by 4, but after the transfer it's going to be 4 by 2. Okay, to get a tensor of 2 by 4 by 2. Similarly, we're going to compute T, which is x0 times W11 transpose. We're going to compute V, which is x0 times W11, and they're all tensors of this dimension. Later on, we are going to apply masking, then we'll apply softmax, then we'll multiply by V, just like we did before, and we'll end up with a tensor of dimension 2 by 4 by 2. Let's call this, I don't know, output 4. Okay, so now let's go to head 2. We're going to compute query to be x0 times, but now in W, so this is 12, this will be 13 transpose. Key is x0 times W14 transpose. Query x0 times W7, sorry, this is 11, 12, 13, 14, 15 transpose, and the result are all tensors of dimension 2 by 4 by 2. Then we apply masking, we apply softmax to end up with output 5. Okay. What output 5? No. Let's call this output 3 and this is output 4. Okay, so we're going to, this is the output of the second head. We're going to concatenate output 3 and output 4 to get a new tensor of dimension 2 by 4 by 4. While just as we did before, we're going to apply a projection. Let's call this output. I'm not really good with names. Let's call it, okay, let's just call it output. Maybe x output 1. We had x output before, so let's call this x output 1. So we're going to say x output 1 times W16. but this is W16 It's a tensor of dimension embedding by embedding. When we take the transpose, it will not change dimension. It's the output of this computation. Just as before, the input of the masked multihead attention, which is x0, the one that we got in the previous feed forward, will be added to the output. So x final will be x output, sorry, plus x output 1, and then layer norm is applied. After this layer norm, the dimension is 2 by 4 by 4. Alright, so this is the output of the masked multihead attention. We can actually just go to the feed forward add-on norm. We are done with this. Now we can go to feed forward add-on norm normalization. So this feed forward has multiple linear layers. Let's start with fully linear layer 1, which is fully connected layer 1. Okay, we're going to say x final, this x final, this one, multiplied by W17 transpose. Well, the dimension of W17 is 4 times embedding by embedding. Remember this embedding this 4, this could be maybe 10. It really depends on you. It's a parameter. We know dimension of x final. We end up with a tensor of dimension 2 by 4 by 16. Then we apply ReLU just as we did, like we did before, to get, well, let's call the x final 2. So let's go to the second fully connected layer. We're going to take x final 2 multiplied by W18 transpose, which W18 transpose has a dimension opposite to this, 4 by 4 times 4. We'll end up with a tensor that has the same dimension as the input, which is 2 by 4 by 4. So from dimension, this has a dimension of 16, it will be from 16 it will be 4, that the dimension. All right, so maybe we can call this x fully connected output. Okay, all right, so to get the final output, like the x output, I'm repeating x output like I did before, so don't let that confuse you. We're going to say this x0, which is the input, not x0, sorry, not that x0, but this, sorry, this x final, I mean, which is the output of the previous layer, the masked multihead attention, which is also the input of this layer. We're going to add it to x fully connected output. Then we apply layer normalization. And the addition and layer normalization will not change the dimension, so it's going to be 2 by 4 by 4. Notice that the dimension of this x is still the same, it doesn't change. So these layers are just really performing computation without changing the dimension. So we are done with the second layer. In the next video, we are done with this block. We'll go into the to this linear layer, then softmax, to see how the predictions are made. You see, remember, our goal is really, for example, given a text, our goal is to predict the next text. So let's see, given this input, we're going to see the probabilities of each possible character that we have. And we're going to take the marks to see if that marks, like the character that is predicted, is really what we wanted. That determines the loss. We will see that in the next video. So we just have this linear layer and softmax. Thank you for watching, and see you later. Bye bye.